Hello students, welcome to this class of fluid mechanics. So in last class we have discussed about pitot tube, right? We are basically studying about the applications of Bernoulli's equation. We have already discussed about venturi meter, orifice meter, and in last class we have studied about pitot tube. We have done one numerical on venturi meter and orifice meter. In this class we will solve a numerical on pitot tube. Okay. So first of all, this was the setup of a pitot tube. Why pitot tube is used? To measure the velocity of flow, right? This was the setup. We have already discussed in last class how pitot tube is used to measure the velocity of any fluid flowing in a pipeline. Okay. So here is the setup. So what's the question? In question, it is given that water is flowing in a pipe. This is water. Okay. This is basically water. Water is flowing in a pipe, and here pitot tube is used to measure the velocity, and it is given that stagnation pressure head is 6 meter. Stagnation pressure head is equal to 6 meter. It is given in the equation. Okay, what is stagnant head? Here, this one, right? We have discussed in last class. This capital H is stagnant head or stagnation pressure head. It is given that it is equal to 6 meter, and static pressure head is given as 5 meter. Static pressure head is given as 5 meter. What is static pressure head? This one, small h, right? This one, small h. This is static pressure head. Okay, so both the heads are given in the equation: stagnation pressure head and static pressure head. Static pressure head is due to pressure at that point only. However, stagnation pressure head is the combination of static head and kinetic head. Why? Because here in pitot tube the velocity came out to be 0. That kinetic head get converted into static head, or that combinedly that's called stagnant head. Fine. So here stagnant head is equal to static head plus kinetic head. And what else is given to us? Coefficient of tube. Okay, coefficient of tube is 0.98. Fine. We have to calculate the velocity of flow. Velocity of flow. This is something that we need to calculate. Fine. Yeah. So, as we have already discussed in last class, we have written the Bernoulli's equation, right? It was like this: P1 by rho g plus V1 square by 2g is equal to P2 by rho g, right? Because V2 is 0 in pitot tube and Z1 is equal to Z2. This was our basic derivation from Bernoulli's equation. And here P1 upon rho g was static head, that is small h here, right? This one, this is small h, and this is my capital H, that is stagnation pressure head. So here P1 upon rho g is small h, that is static head, plus V1 square by 2g. This is V1 that we need to calculate, that is asked in the question, which is equal to P2 by rho g. What is P2 by rho g? That is my stagnant head. What is stagnant head? It is given in the equation as 6 meter, right? It is capital H. Fine. So here I can write small h is 5 plus V square by 2g is equal to capital H, which is equal to 6, or which also implies V is equal to, or let's write simply, V square by 2g is 6 minus 5, which is also equal to 1. So V is equal to under root 2g. Fine. V is equal to under root of 2g. Now this is my ideal situation. This is only ideal case, but here in the question coefficient of tube is given to us, that is 0.98. So we have calculated practically velocity actual is equal to coefficient into the actual velocity into theoretical velocity that we calculate is under root 2g, which is also is equal to 0.98 under root 2 into 9.81. Fine. After calculation, you will see that it came out to be 4.34 meter per second. Okay, it was very simple use of Bernoulli's equation. Similar numericals can be asked to you in your exams, where stagnation pressure head could be given, or any two quantities will be given, third will be asked. Okay, so stagnation pressure head was given to us, static pressure head was given to us. Keep it in mind, either the coefficient of tube will be given to you, the coefficient of device that you are using, or it might not be given. So while solving the numerical, you need to write there that I am assuming the ideal case, or if you are assuming some coefficient, then you please write that, mention it there. Okay, this is how velocity is calculated using B.Tech tube. I hope it's clear to you. It was a very simple use of Bernoulli's equation. If you have any doubts, please put it in comment section. We will meet in next class. Bye bye.